Hi students, this is our piecewise lesson, the first one that we did, and I'm just going to go through some of the questions with you to make sure we're on the same page. Okay, let me get past some of these here, sorry. So our learning goal for this is to evaluate piecewise functions from a graph and an equation. So we're going to evaluate, and then we actually got into doing some of the graphing as well. So that took us a little further, and I'm going to go ahead and show you that to make sure we're okay. So the criteria for success, whenever I ask you to evaluate, you need to choose the appropriate function to input the value based on the restricted domain. You're going to show your work and perform the proper order of operations. And then when you're identifying the domain and range, you're going to use appropriate inputs and outputs for the function and appropriate notation. Now, when we're talking about the notation here, we're going to use this interval notation. So if I wanted to say, oh, the domain is everything greater than or equal to 2, what we're going to write is we're going to write a bracket, 2, infinity. Now, what this means is that this bracket includes the endpoint of 2. And since we have this equal to here, we would have to use the bracket. And then this original statement says it's every number that's greater than or equal to 2, which means we'd have to go all the way to infinity. Now, whenever there's an infinity, we will have that parenthesis because you can never reach infinity or negative infinity. So we use the parenthesis for that. Now, let's say we had something that is x is less than 5, or x is greater than or equal to 7. Let's say that's what we have. So how would we write this? The x is less than 5 is going to tell us we're going from negative infinity to 5, but we do not include 5 because it's just a less than. There's no equal to. What we're going to do is we're going to use this U symbol as a union, and then the second part says x is greater than or equal to 7. So that means we're going to use a bracket for 7 and go all the way up to infinity. So these are some of the new notations you will get used to seeing. The last one I want to kind of reflect on here is you've probably seen this for all real numbers, or you just write all real numbers. What we're going to do for interval notation is we're going to say, hey, we're going to go from negative infinity all the way to infinity. And that's how we would use the interval notation. Okay, so for this warm-up, this is the graph of f. So this is our f of x. And we want to evaluate and find f of negative 3. So when I look at this, f of negative 3, we see this point when I have an input of negative 3, my output is 0. So that answer would be 0. And again, what we're thinking is that we have the point negative 3, 0. So when the input is negative 3, the output is 0. Okay, for our next one, it's saying what is f of 0? So for this next one, when I plug in 0, I output 1. And for the last one, f of 9, what I like to do is get to the x-axis at 9 and then just follow it down until you get to the graph. And for this one, we're here at negative 6. Now we're looking for domain and range of this function. So when I'm looking here for the domain and the range, if you have a graph that's touching the edge of those grid lines, you're going to assume that the graph continues in that same manner forever. So in this case, I can use any x value I want. So we're going to say the domain is all real numbers, and this is the way we'll show it. Now, when we're looking for range, we're looking to see what is the highest output I could ever get for the y value, for the output. And it's right up here. The value of 1 is the highest output we're ever going to get. And then it's going to go down forever to negative infinity. So the range, we would say from negative infinity to 1 with a bracket because I'm including that point. That point 1 is included in the range. Okay, for piecewise function, a function has different pieces for the different parts of the domain, and it might be continuous or not. And obviously feel free to pause and jot down notes or questions as we go through. So this is our continuous function, and an easy way to tell is if you can go the entire way without lifting your pen or pencil, then you know you have a continuous function. Now discontinuous, you can see here, I'm going up, and then we have this open circle, and I'm gonna lift my pencil, and then I continue on my way. So this is actually what's called a jump discontinuity. And we'll go into more detail with discontinuities, but also I want you to take note that this is open and this guy here is closed. So when, let's say this function was called f, if I wanted f of 1, the answer would have to be 1. It couldn't be -4 because it's an open circle right here. So we're not allowed to use it. And for it to be a function, every input has exactly one output. So if these were both closed circles, we'd have a problem. We would not have a function anymore. Okay, so here is our graph g of x, and we're going to try to find all these different values. And I just gave you one of the answers. So g of 7, again, we kind of go up until we hit the graph, and then we look for the y value, which is 7. G of 1, so again, we're here at the x, and this one we have to hit right here. Okay, so we're hitting here at 1, that's what we just talked about, and then g of -2, I would go ahead, go down, hit the graph, and it's at -7. Domain and range. So again, we're gonna assume that this keeps going in both directions here, forever and ever, because it touches the edge of the grid. So even if there's not an arrow, that's going to be our notation for implying that it goes forever. So if we're looking for the domain, we want to think, is there any number I'm not allowed to plug in for an input? And the only space I see that's kind of a question mark is this. And we're like, well, it's broken. Is everything okay here? If you plug in 1, you get an output. You're fine. So the domain is all real numbers. Very boring. No issues. The range, again, we're looking for what are our range of outputs, and this is the highest output, and then everything else keeps going to -infinity, okay? So when we're looking at end behavior, it's going to -infinity. So we have a maximum at 10, so we're gonna say, oops, I didn't wanna do a bracket. We're gonna say -infinity to 10 with a bracket, because we include that 10 in the range. Again, infinity and -infinity will always have a parenthesis because we can never actually reach those numbers. Okay, so now we have the formulas of the pieces are right here. And then we have the domain of the pieces are these right here. So we can see in this one, we have a linear piece, we have a quadratic piece, and we have an exponential piece. And these three functions we're going to use only at the indicated domain. So we're going to use part of a linear function, part of a quadratic, and part of an exponential. So if we have these inputs, the big thing here is to find out where does that input live, okay? So for f of 3.5, we want to look, hey, does 3.5, is it less than or equal to -1? I would put 3.5 here. And I'd say, hey, is that true? No, that's not true. So there's no way it can be in that first piece. Then we'd say, hey, what if we put 3.5 here? Would that fit? Is 3.5 less than 4 and greater than -1? Yeah, that fits right in between. So for this one, we're going to use this piece of the function. So this is 2 times 3.5 squared. Okay, so for this one, so we have 3.5 squared, and then times 2, and we get 24.5. Okay, so for the next one, we are looking at -1. So we want to know, where does it live? Well, let's see. If I test it out here, is -1, so we're asking a question, is -1 less than or equal to -1? Yeah, the equal to part, that works perfect. So we would end up using this piece. So this would be -1 minus 6, which is -7. And then for the last part here, let's see, orange might work. Okay, the last part is f of 4. Now, here's a little bit of trick here. We look and we're like, and actually it was the same with the -1s, but let's just look at the one with the 4. So this says that your x value should be less than 4. Is 4 less than 4? No. But what about if we put it here? Is 4 greater than or equal to 4? Yes, that is a true statement. So we're going to go ahead and put it into here. So we have 10 to the 4th. Okay, so let's see here. 1 second. All right, let's take a look at this one. Okay, so this is complete the table for function w defined below. This is different than what you had in your original table and function just by a bit. But this would be good for you to try again just as a different one. So we're plugging in values. So I'm looking at from -3 to -1, I'm going to use this function because those are part of this restricted domain. So I'm going to use this function right here. Now, there's nowhere to plug it in. It's a constant function. So these are all going to be 5. Okay, for the next one, I did include -1. Now, it's a little confusing because, hey, it doesn't say -1 belongs here, and it does not. But we want to know, where can I plot that open circle? Okay, so we're going to plug that into this second function. -1 squared is 1, plus 4 is 5. But I am going to write that this is an open circle. So this is kind of just a little placeholder. We're going to draw that circle. We know it's not actually part of the second domain, but we're going to use it just to find where to plot that point. And so for the rest, we'd have 0, 4, we'd have 1, 5, we'd have 2, 8. Okay, so here's for that second function. Now, for the third function, notice I have another repeat of 2. And of course, it's actually not in this domain, but it will help us to find the open circle place. So if I put a 2 in, I get -2, absolute value is 2. And again, I'm going to write open circle. Okay, so for the rest of this, I get a 1, I get a 0, and a 1. Okay, now if we are going to graph this, and I'm going to try to fit this all on the same page so I can actually read my table. So this might get a little bit crazy looking. Let's see, we're going from -3 to 5, and the highest we want to go is 8. Okay, well, this might be a little tricky, but we're going to try to make it work. So -1, 2, 3, and we're going up to 5. 1, 2, 3, 4, 5. And the highest we have to go up to is 8. And the lowest is 0. Okay, so I think this will work all right. So let's go ahead and plot these in the same colors. So for -3, -2, and -1, we all have 5. So we have this, this, and this. Now this restricted domain says for every input less than or equal to -1. So we know that we want to go ahead and continue this way forever to -infinity. So all those inputs in between, we didn't plot all those on the table, we didn't plug them all in, but we know that those are all going to be 5. Okay, the next piece here, let me grab pink, is this quadratic. Okay, so for the quadratic, we can see that this actually is a vertical shift up 4 for the vertex. And then we have -1, 5, open circle. Now look what happens. That's an open circle right over the closed circle. So when you draw this, I will have no clue that there's an open circle there. It fits perfectly right over it. So it's like it's seamless. You wouldn't even know. And then we have 1, 5, and 2, 8. So here is this part. Okay, now again, it says only use the parabola between 2 and -1. Now the last one here is using this absolute value for x is greater than 2. Now we can see there's an open circle at 2, 2, so I'm going to go ahead and plot that open circle. Okay, and then it's going to be 3, 1, 4, 0, and 5, 1. Now it does go forever greater than 2, so I am going to continue this, and this will just be that little piece. Now notice, it's closed here and open here, which means it is indeed a function. The input of 2 has a single output. And this would be what this crazy graph looks like. So this is a piecewise graph. You're using only each of these 3 pieces only for the domain that is given. Okay, state the domain and range. Let's do that here too. So let's go ahead and look at our domain. So domain for this one, I could plug in any x value I want and we would be fine. So this is an all real situation. There's no troublemakers here. Now let's think about the range. So the range, I can see that we do have a minimum here. So this point is the lowest output you're ever going to get. So for the range for this, it would be bracket 0, because I include that point in the range, up to positive infinity. And that would be your range. Okay, so the criteria for success for graphing the piecewise function is every part of the graph is in the correct domain area. So you're only showing me the part of the parabola that should be included. Discontinuities or continuous connections are shown clearly. The end behavior is shown clearly, and the shape of the function is appropriate. So that would be when we look at our graph, we only have the absolute value from here to then forever to the right, okay? We also are showing that this is open very clearly. There's no question, that's open, this is closed. And then this is what we're talking about with our end behavior. It's either touching the edge of the grid, or you can put a little arrow to indicate it's going to go forever in that direction when we're talking about the left and right hand behaviors. And then the shape of the graph, we think of the parabola. This should be nice and smooth. It should be a curve. The absolute value should be very rigid. It's 2 linear pieces connected at that vertex. So you want to make sure that you're taking the time to show the appropriate shape for each function. Okay, so that is the basics from that lesson. And thank you for taking the time to watch this. And as always, please jot down any questions you have, and we can go through those together in office hours or in class if we have time.